Ooh. Good morning. This is Professor David J. De Los Reyes. It's February 14, 2023. Happy Valentine's to everybody. Okay, my topic for this morning, it's already this morning here in Los Angeles, California. My topic for this morning is a topic on the application of trigonometry. Okay, let's proceed. Oh, I try to bring out the figure so I could bring out the problem. We got a building here. The height is 300 feet. And this is a horizontal ground. On this horizontal ground, we got two observation points. Meaning we got a surveyor here at point A. This is point A over here. And we got another observer at point D. So meaning we got a surveyor transit over here. And we got the first surveyor transit at point A. So this is point A and this is point D. The problem is asking the total distance between A and D with the given conditions. That when the first observer erected the vertical line over here, which is 5 feet, and 6 feet from its observation point. This is a vertical stick, and this is a vertical stick. So, when he looked up, the angle of inclination of the building over here, this height here is 5 feet. And its distance horizontally from the first observation point A is 6 feet. On the second one, they erected again a vertical stick, which is 6 feet, and its distance from the observation point is 3 feet. So meaning this is 3 feet and this is 6 feet to observe the top still of the building. If the total width of the building horizontally is actually 20 feet, how far is the distance A to D? Oh, actually, this problem here is an application problem of the so-called trigonometry. Okay, I will try to check my camera. This is now the so-called importance of trigonometry in real life. So the problem is asking the total distance AD, distance from A to D, with the given condition that this is 5 feet, this is 6 feet, the width of the building is 20 feet, this is 6 feet, and this is 3 feet, and the height of the building is 300 feet. Okay? Later on, we could find that the importance of these vertical distances actually gives us the angle of inclination of the top of the building. Because the surveyor here didn't give us the angle of inclination. He just gave us this height here and this distance. This height here and this distance. Okay, let's try to bring out the solution. To bring out the solution, we shall try to bring out a right triangle on the left hand side. We bring out this right triangle here. That is on the left. It should be something like this. This is 300 feet, the height of the building. Okay, this is distance A to B. This is 6 feet, and this is 5 feet. This is a vertical line. We assume that the building is also vertically erected. It's not tilting. Because if it's tilting, that's a different story. So this is a vertical line, and this is a horizontal line. That is actually our first right triangle. And from the first right triangle, actually we can now compute for the distance AB. Okay? To compute for the distance AB, for the smaller right triangle, okay, 5 feet is opposite, 6 feet is the adjacent, And if we take the tangent, the angle of inclination is designated by theta. This one here. So if we take the angle of tangent of theta, the tangent of this angle here should be opposite over adjacent. So it will be 5 over 6. And again, taking the tangent of this angle here, it should be the height of the building all over the distance AB. So 5 over 6 is actually equal to 300 over AB. And the only unknown now, if we try to remove this one, okay, this is 5 over 6 equal to 300 over AB. AB now will be equal to the product 6 times 300. This is divided by 5. This is divided by 5. And AB is actually 360 feet. The distance from A to B is actually 360 feet. Okay, it is from this point here up here. And bringing out again the remaining right triangle on the right, it will be this right triangle over here. This is the height of the building, 300 feet. And this is 6 feet, this is 6 feet. Vertical line, and this is horizontal line, and this is 3 feet, right? And the distance from the base of the building, considering the right hand side, is actually from point C to D. So this distance here should be CD. And if we try to designate the angle here, the angle of inclination on the right hand side, I designate that as alpha. We take again the tangent of alpha. The tangent of alpha will be opposite over adjacent. So considering the smaller right triangle, it will be 6 over 3. And this should be equal to, considering the bigger right triangle, it should be 300. This is over CD. So tangent of alpha is actually 6 over 3, and this should be equal to CD. Okay, and if we try to remove this one, 6 over 3 will be equal to 300 over CD. The only unknown is CD. So CD now will be the product 3 times 300. This is divided by 6. So 300 divided by 6 will be 50. 50 times 3. So CD is actually 150 feet. As simple as that one. So the distance CD is 150 feet. Okay? That is from this point here up here. And the problem is only asking the distance from A to D. So there's no problem. We can now formulate our last equation, that is the distance AD will be the distance AB plus the width of the building plus the distance AD. So I place it here. The total distance from point A to point D should be AB plus 20 plus CD. So this should be 360 plus 20 plus 150. And the distance AD is actually 530 feet. Okay, that's it, guys. That's the application of trigonometry in real life problems. That is in the computation of distances. Okay? Actually, if the horizontal distances are given, actually, even if the height of the building is unknown, actually we could compute for the height of the building by using trigonometry. Okay, that's it, guys. So for those who are taking up trigonometry, this is for you guys. So if you would like to subscribe to my channel is at youtube.com/@Prof. Okay, if you want to subscribe, and if you want to share it, please click share. The topic is trigonometry and real life problems. Good morning, Los Angeles.